Dear students, today we shall discuss the chemistry paper 6 of BSc syllabus of Kuvempu University of 5th semester, that is session 11. In this session, we will try to know different types of molecular spectra, that is rotational spectra, vibrational spectra, electronic spectra, and Raman spectra that are to be mentioned here. When we look at our previous session, we had discussed about the origin of molecular spectra, that is Born-Oppenheimer approximation. The learning objectives of present session is to know particularly about the rotational, vibrational, electronic and Raman spectrum. The outcome of the present session is that the students can understand the different types of molecular spectrum, particularly rotational, vibrational, electronic, and Raman spectroscopy. We all know that the electronic energy is greater than vibrational energy, which in turn greater than rotational energy, and the order of magnitude estimates the typical energy scales in a transition. Based on this, we can distinguish different types of molecular spectra. For example, based on the electronic energy, vibrational energy, rotational energy, we can have the rotational, vibrational, electronic, and Raman spectroscopy. Let us see what is rotational spectroscopy or rotational spectra. The rotational spectra are transition between the rotational levels of a given vibrational level in a particular electronic state. Only the rotational quantum number J changes in these transitions. These spectra lie in the region of microwave or in the far IR region. They consist typically of a large number of closely spaced, nearly equidistant spectral lines. The selection rules for the rotational spectra are delta J is equal to plus or minus 1. Now coming to the vibrational spectra or rotational vibrational spectra. The rotational vibrational spectra consists of transitions from the rotational levels of a particular vibrational level to the rotational levels of another vibrational level in the same electronic state. So you must understand here the rotational spectra, because of the transition from rotational levels of a particular vibrational level to the rotational levels of another vibrational level in the same electronic state. The electronic excitation state thus remains the same because the transition occurs in the same electronic state between the two rotational energy levels. The quantum numbers J and V change, means the rotational quantum number and vibrational quantum number characterized here. These spectra lie in the IR region. They consist of a number of bands, that is groups of closely spaced lines, and the selection rules for the rotational spectra are delta V is equal to plus or minus 1. Now coming to the electronic spectra. Electronic spectra consists of transitions between rotational levels of various vibrational levels of one electronic state to the rotational and vibrational levels of a different electronic state. It is not like rotational spectra. Electronic transitions tend to accompany both rotational and vibrational transitions because it is a transition between two electronic states, and each electronic state consists of both rotational and vibrational levels. It contains all the vibrational bands of electronic transition being observed each one with its rotational structure, and the selection rules is equal to plus or minus 1. Now coming to the Raman spectroscopy, it is a spectroscopy in which the radiation at a certain frequency is scattered by the molecule with shifts in the wavelength of incident beam. The Raman scattering is actually if a photon of energy greater than delta E is absorbed by a molecule, a scattered photon of lower energy may be released. The angular momentum selection rule becomes delta L is equal to plus or minus 2 in the case of Raman spectroscopy, and it is associated with the IR absorbance. The overall session summary is the rotational spectra are the transition between rotational levels of a given vibrational level in a particular electronic state. Rotational vibrational spectra consists of transitions from the rotational levels of a particular vibrational level to the rotational levels of another vibrational level in the same electronic state, and electronic spectra consists of transitions between rotational levels of various vibrational levels of one electronic state and the rotational and vibrational levels of different electronic state, and the spectroscopy in which the radiation at a certain frequency is scattered by the molecule with shift in the wavelength of the incident beam is called the Raman spectroscopy. Now let us look at a few multiple choice questions. The rotational spectra are transitions between the rotational levels of a given dash level in a particular electronic state, and the options are rotational, electronic, vibrational, none of the above. And the answer is vibrational level. Second question is rotational vibrational spectra consists of transitions from the rotational levels of a particular vibrational level to the dashed levels of another vibrational level in the same electronic state. The options are electronic, rotational, vibrational, none of the above. And the correct answer is rotational level. Third question is electronic spectra consists of transitions between the rotational levels of the various vibrational levels of one electronic state and the dash of different electronic state. The rotational and vibrational levels, electronic levels, none of the above. And the correct answer is rotational and vibrational levels. And the fourth question, the spectroscopy in which radiation at a certain frequency is dashed by the molecule which shifts in the wavelength of the incident beam is called Raman spectroscopy, and the options are reflected, transferred, diffuse, scattered, and the correct answer is scattered. You can go through these textbooks: Principles of Physical Chemistry by Puri Sharma and Patania, Textbook of Physical Chemistry by Gurudev Raj, Molecular Structure and Spectroscopy by Arul Das, Molecular Energy Transfer by Levin and Jortner, Physical Chemistry A Molecular Approach by Donald A. McQuarrie. Thank you for watching this video.